Hello, welcome to Team Rocket's Blasting Off Again presentation of what is a railgun. Now, the definition of a railgun is a weapon consisting of a pair of parallel conductive rails using a magnetic field and electric current to launch projectiles at very high velocities. Now, don't worry if that seems like a lot. We're going to get into the specifics and nitty-gritty of what actually that means in a little bit. So really what a railgun consists of is a power source, pair of rails, and a moving armature. Now the power source is what's going to supply your current going through the rails that will propel your projectile. And in these types of railguns, often the current is very, very high, and we'll see why. Now the parallel rails are important because they're what generates the force that's going to propel your projectile. Now, that means they are a pair of conductive metal lengths, and they extend as long as you need them to for the projectile. Typically 4 feet to 30 feet, but it can be much, much longer. Now, the moving armature is your projectile, and it bridges the gap between the rails. Now, the portion of the projectile that actually completes the circuit can either be built into the projectile itself, or it can be part of a conductive sabot. And a sabot is basically just a package that you put the projectile in that then falls away once it's been launched. Some projectiles even have their conductive material on the back, and when it's launched, the high currents end up vaporizing this, and that vapor, or plasma, is what carries the current, and these types are called plasma armatures. Now, what exactly is a railgun? We know, but how does all this work? Now, why does pumping so much current through this loop actually move a projectile? Well, that's explained by something called the Laplace force, which is derived from the Lorentz force, which is an expression of the force on a charged particle going through a magnetic field at a certain velocity. Now, for our application, which is current flowing through a wire, that can be simplified to the expression you see here. Force equals the length of the wire times the magnitude and direction of current cross product with the magnetic field. Now, all that means is the force that results from the current going through here is dependent on the length of the wire exposed, the magnitude of the current, the magnitude of the magnetic field that the wire is exposed to, and the angle between the magnetic field and the wire. So for ours, we can simplify it to just L times I times B. Now, in terms of the direction of the force, this is another implication of the cross product. If you use the right-hand rule and you have your I cross B, then your thumb will point into the direction of the force. So for example, if the current flows left in a wire exposed to a magnetic field pointing into the screen, the force is going to act downward based on the right-hand rule. Now, one of the interesting results of this is your force is completely dependent on the current. So one of the nice things about railguns is you can actually dial in the specific amount of force you want just by changing the current. When you increase the current, you increase the force.
All right, moving on to history. The very origins of the railgun started way back in 1844 with a guy named Mr. Benningfield. It wasn't really a railgun to say, but he advertised an electric gun in a newspaper, that said would promise to revolutionize the battlefield. His revolution never really came, and it just sort of faltered. But it did help promote the idea of a gun that's like electric and everything. Then in 1918, there was another origin of a railgun came about when a French inventor, Louis Octave Falcon Philippe, filed a patent for a electric cannon, and it was basically a very rough version of the railgun, and it led to Joachim Hansler in 1944 to create the first working railgun, and it had propelled 10 grams of mass to speeds of 1 kilometer per second. And the next big event was in 1972, and this year was important because they changed from solid metallic armatures to plasma arcs, which allowed for railguns to go from speeds of 1 kilometers per second to about 6 kilometers per second, so that was pretty big. And this paved the way for future railguns to have much higher velocities.
And now we move on to applications, which are very plentiful. For one, it is the U.S. Army and Navy, which are using the railgun as ammunition and a form of weaponry. It comes in the form of small tungsten missiles, and as we know, tungsten is an extremely strong element in metal. Some of the benefits of using this as ammunition is that it is relatively light, and it is easy to transport and handle, and it is less susceptible to bullet drop and wind shift. And as of right now, the U.S. Navy plans to test their railgun in 2016 and 2018 in order to use it in the battlefield and potentially if war would come about. And another application is the Strategic Defense Initiative, which is also known as Star Wars, which is the development of a space-based system. Its purpose is to defend the nation from attack from missiles of any sort, and it would attempt to do this by firing projectiles at those missiles, or if need be, at incoming asteroids. And the picture on the right is a representation of the interception of the missiles.
Alright, these are some potential applications that'll be helpful in the future, or that scientists think could happen in the future. Space, well, that's what our topic is basically about, space one. It's supposed to help. Scientists think we can use railguns to help launch rockets and other projectiles into space. And another application is nuclear fusion. Since railguns produce such high velocities, and with those high velocities comes extremely high temperatures and pressures, which leads to fusion. Scientists think that fusion can be possible with the railguns, but as of now, the railguns that scientists have can't generate the energy for fusion to occur. So, yeah.
And since railguns seem like such a benefit, how come they're not used commonly right now? Well, that's because there are many drawbacks to using a railgun. In this case, four. For one is the power supply. In railguns, we use relatively small capacitors, and in order to use a railgun, we need to have 180 megawatts of energy, which is enough to power approximately 50,700 homes each year, which, as you can see, is a lot of energy and would take a lot of power. The second one would be resistive heating, which is caused when the electric current flows through the conductor. It creates resistance, and because of that resistance and that current, it excites the rails molecules in the rails, which causes intense heat that could possibly have negative consequences. And the third drawback would be melting, which from the intense heat that we get from the resistance and the current, the rails can possibly melt from that intense heat. And the fourth and final drawback is repulsion, which the current runs in both rails, and that current runs in opposite directions, which creates a large repulsion force because there's such a large current. And because of that large repulsion force, it causes the rails to possibly push apart.
Okay, what's next? This is basically an extension of potential applications. So the U.S. Navy is investing a lot of money and time into railguns because they believe it's very useful for the safety of the nation. And they have a prototype set for 2018, and they think they can install a fully functioning railgun in 2028. So the future looks bright for the Navy. And also NASA, they want to create an effective launch system. And there's already studies based on the kind of launch system. So there's still also like the Navy testing and prototyping, all that kind of stuff. And science and engineers are really hopeful about this technology.
So, in summary, a railgun. Alright, let's wrap up by going back over exactly what a railgun is and how it works. So, the railgun consists of a power source, a pair of conductive rails, and a projectile that completes the circuit. The projectile is propelled by the interaction between the current flowing through the projectile interacting with the magnetic field created by the two rails, and this creates a force that propels the projectile down the track.
Alright, so prove your knowledge. First question. Who created the first working railgun? Joachim Hansler.
What is the Lorentz force and how is it created? The Lorentz force is the product of the length of the wire, the current, and the magnetic force, and it is created when the current in the crosswire interacts with the magnetic field.
And now the third and final question is name 2 drawbacks of using a railgun. Now, if you said either power supply, resistive heating, melting, or repulsion, you would be correct. And you received 3 check marks. Thank you for viewing our presentation about what is a railgun, how it works, potential applications, and specific drawbacks of using a railgun. We hoped you learned something by watching this presentation.